In today's notes, we're going to talk about how to shift our trig functions, sine and cosine, vertically and horizontally. We've already talked about changes in these graphs using a change of amplitude, which is multiplying the y values by the a in front, or by changing the period of the graph, which is a change of b. It changes your x values, which causes the graph to the sine or the cosine period to either become longer or shorter. So these two things, the amplitude and the 2 pi over b, which gives us the period. We also talked about rearranging that formula so that we have 2 pi over the period equals our b value whenever we're getting ready to write our own equations. So both of those are important. But today we're going to talk about shifting our graphs left and right, up and down, the same that we've done with every other function. So this part is actually pretty easy. We're just going to move the axis. We're going to have a new pretend translated axis, and then we'll just graph on our new axis just like we did before. So let's go ahead and step into our first example here. The first thing we probably want to do is move this 1 out here to the end. So it's y equals 3 cosine of pi force x minus 3 plus 1. So we can tell that our left-right shift is inside here with x. We're going to go 3 units to the right. Our up-down shift out here on the end, 1 unit going up. All right, so by using the parent function points from the cosine function, the original cosine function points, we're going to multiply the x values by, and we change the x's according to what is inside here. So we're going to change the x's by this pi force, but remember that we're dividing by pi force, which means we're going to multiply the x's by 4 over pi. And we're going to multiply the y values by the number that's in front here, which is 3. So I'm going to go ahead and make a list of all of my original values for the cosine function. So cosine starts at 0, 0, and then we have pi half, starts at 0, 1. Then we have pi halves 0, pi, negative 1, 3 pi halves, 0, and 2 pi, 1. Okay, so we're going to make these changes to these points. So let me move this up just a little bit so you can see. Okay, so I'm going to write my new points over here. So we're multiplying the x's by 4 over pi, so 0 is still 0. Pi over 2 times 4 over pi would be 4 pi over 2 pi, and 4 pi over 2 pi, pi's are going to divide out, 4 over 2 is just 2. All right, pi times 4 over pi would be 4 pi over pi, which is just 4, and then you can probably see the pattern, 0, 2, 4, 6 is what we're going to get when we multiply 3 pi over 2 times 4 over pi, so that would give us 12 over 2, which is 6, and then 2 pi over times 4 over pi would give me 8. So I've multiplied my x's by 4 over pi. Now I'm going to multiply the y's by 3. So 1 becomes 3. 0 stays 0. Negative 1, negative 3. 0, 0. 1 becomes 3. So these are going to be the new points that I'm going to graph. Now, I'm not going to graph these with this as my origin, though. I'm going to translate my axis. And then I'll use the translated axis as my new origin. And so this is where we take our horizontal and our vertical shifts. So we're going to the right 3 units. And we talked the other day about pi is approximately 3.14. So when we're going 3 units to the right, we're going about pi units to the right. So we're going to say that this is my new shift to the right, pi or 3 units. And we're going 1 unit up, so this would be my new x-axis. And this is where I'm going to start graphing from. So I'm going to pretend that this is like my origin. And so now I'm going to graph my points. So I've got 0, 3. So I'm going from here up 3. So 1, 2, 3 puts me up here at the very top. Then I'm going over 2 units. So remember, these are double boxes over. There's 1, 2, 3. So every 2 boxes is 1 unit. So I'm going over 1, 2 units, 2, 0. Then 4, negative 3. So this is 2, 3, 4. And going down 3, 1, 2, 3. Let's get over this a little bit. All right, and then the next one's not going to fit on here. It would be out in here. That's 6, 0. So I'm going to go back the other direction and put some points on my graph. So I know my spacing now is every 4 boxes or every 2 units. So I'm going back 4 boxes or 2 units. We're coming back down to 0, going 4 more, and going down 3. 1, 2, 3. I could go 4 more. Let's see, where am I? And be back at 0. I could go 4 more and go up 3. So I have plenty of points here now to complete my graph. So here's 1 rotation, 1 cycle. Here's a part of another one. So I need at least 1 full rotation in your graph. All right, I hate that it didn't print on the same page, but on the next page of your notes, you'll see your domain, range, amplitude, and period. So my domain, this thing is continuous. It just keeps going. Domain is all real numbers. My range, be careful. We know that we went up 3 units and down 3 units, but that is not my range. My range, remember, is from the actual origin. So I actually am just going down 2 units and up 4 units. So my range goes from -2 to 4. And then my amplitude, of course, that's what I multiply my y values by. It's the number in front, so that's going to be 3. That's how high the wave goes off of my translated axis, 3 up, 3 down. And then the period of the graph is how long it takes for it to complete a cycle from high point to high point or low point to low point. Or we said we could always just look at the end here, because the period, remember, is 2 pi divided by b. And we've already done 2 pi divided by b when we found this last value here. So our period is 8. Okay, so in our second example, we're going to go ahead and move this plus 1/2 out to the end, minus 1/2. And then we can see our horizontal shift. We're going to the right, pi over 2 units. Our vertical shift, we're going down 1/2 of a unit. We're going to multiply the x's by the number that's in front of x. Well, you notice here that there is no number in front of x. So we're just multiplying the x's by 1, or really not changing them at all. The y values, we're going to multiply them by the number that's in front. In this case, that would be by -2. So let's make a list of our points, the original points for sine. So we have 0, 0, pi halves 1, pi 0, 3 pi halves -1, 2 pi 0. Okay, so I'm going to make my changes, make my new list over here. So let's do the x's first. The x's are multiplied by 1 or no change at all. So we've got 0, pi halves, pi, 3 pi halves, and 2 pi. Now for the y's, we're multiplying by -2. So we get 0, -2, 0, +2, 0. So we know that since we multiply by 2, it's going to stretch the graph a little bit. And because we multiply by a negative, it's going to reflect the graph. So the original sine function graph, remember it goes up first and then down. So our new graph is going to go down first and then up. All right, so let's go ahead and do our translated axis here. So we know we're supposed to shift to the right pi halves units. So right pi halves is my new y-axis. We're going down a half. These are in double boxes, so half would be down one box. And that's my new x-axis. So this is my new translated origin. This is where I'm going to graph from. So this becomes the 0, 0. Pi halves, we can see here that pi halves is 3 boxes. So I'm going to go 3 boxes to the right and down 2 units. So double boxes, that's going to be 1, 2, or 4 boxes down. And then pi 0, pi is 6 boxes out. So from here it'd be 6 boxes over, or 3 more boxes from where I was, 0. And then 3 pi halves, so 3 more boxes and up to 1, 2. And then 3 more boxes, and I'm going to have my 2 pi, 0. And that's going to be a complete graph right there. One full rotation. Now, if you want, you could go back the other direction, just like we did on that last problem. 3 boxes back, and where's my graph going? Because it has to continue this exact pattern. It's going to go up 2 units, and then 3 more boxes back at 0, 3 more, and it's going down 2 units, 3 more, back to 0, and that's another full rotation. Now you only have to give me one rotation in your graph, but I just want to make sure you understand the pattern continues. This doesn't do this pattern and then start down. It has to continue a smooth curve. All right, so my domain, all real numbers. My range, well, from the actual origin, I'm down 1, 2.5. And I'm going up 1.5. So negative 2.5 to 1.5. Or if you wanted fraction form, the -5 halves to +3 halves. Our amplitude, that's how high our wave is. It's also the number in front, but remember, amplitude is the absolute value of the number in front, so it's +2. The height of our wave is 2 units up, 2 units down from our translated axis. And the period of our graph is 2 pi divided by b, but we've already done that. And this time our b value is just 1, so the period of the graph did not change. Still 2 pi. Now I'm going to write just a few things down here that might help you when you're graphing, that you might want to write down, like we were just talking about here, that pi halves is 3 boxes. Pi 6 is 1 box. Pi fourths is going to be 1.5 boxes. So that sort of thing will help you. Pi is 6 boxes. And remember too that in normal units, if it doesn't end up in pi units, then left and right, pi is going to become 3. So every 2 boxes, it'll be double boxes. 1, 2, 3. So hopefully this will help you out some right here too if you're having trouble with the fractions. Now, with that said, you should be able to graph any sine or cosine graph that has an amplitude change, a period change, a left-right, or an up-down translation. So these values, just like any other function, are going to change your x's and your y's, change your shifts.